Hello, my name is Michael Rue, and my project is on GAN network application towards face restoration. The main focus of my project is to study, in general, GAN architecture, starting from the more simple ones, such as DC GAN, going to up towards style-based architectures, and going towards super resolution models, as well as models that are focused to take in degraded low-quality images and output a high-quality image. At the end of my project, I also did an additional experiment regarding a different way to sort of see how a model uh, enhances an image by running the same image through the super resolution model over and over repeatedly and seeing which sort of features and how the image changes and seeing what that might say about the architecture of the model itself. So I first started with DC GAN, which is the simpler model and one of the models I trained and coded. So I started with DC GAN into style GAN 288, which is a style-based architecture. Here's the diagram comparing a traditional GAN to a style-based GAN. We could see that the traditional GAN takes in a latent code Z directly as input, and the latent code Z doesn't get transferred or sort of skipped as a residual into higher resolution or future convolutional layer blocks. But in style-based architectures, it takes in the latent code Z, runs it through multiple fully connected layers, gets us an intermediate code, latent code W, and we can see that it is actually placed within each uh, convolutional block. So GPEN, or GAN Prior Embedded Network, is a model that was created to tackle blind face restoration in the wild. So it is meant to take a low quality degraded image. The degradation can come in various ways: JPEG compression, blurring, noise, entire sections of the output completely erased, and give us a high quality image of what it believes that the low quality image originally would look like if it were high quality. As we can see here, there's a model of the network. We can see it takes in a low quality image, goes through an encoder. It then, in order to retain the features of the low quality image, it has to pass the shallower features ahead to the GAN prior network it uses in order to create a higher quality image that still retains such things as the background and the facial structure of the person or image. Then I went to real ESR GAN, SR GAN. So real ESR GAN is the actual model I had tested on, but I wanted to give a little bit background on SR GAN, ESR GAN, as they're sort of the foundation of real ESR GAN. And I sort of went into the different workings and how they build up upon each other. Then I went to the outputs of each of my models. So DC GAN model, I trained on the flowers 102 dataset, and then I generated an output of some fake flowers. And then I also analyzed the discriminator against generator loss, which, as we can see here, the discriminator quickly converged to 0, while the generator continuously increased in loss, which is an issue. And I started to talk about why this might have happened, as well as how to solve this issue. So StyleGAN 2 ADA model, I'd use this in order to show the impact of the latent code as sort of controlling different aspects of the person, as this will be used later on in such as like the GPEN model, where it takes this sort of style-based architecture as a generative prior for its architecture. And here's like an example of a GIF doing bilinear interpolation of the latent code Z, and how changing the latent code Z ultimately changes the output image in different ways. Then I talked about the GPEN model versus the real SR-GAN model. So I've taken both of the outputs from this model, put it through different image quality assessment metrics, such as SSIM, PSNR, which stands for peak signal noise ratio, and sort of compared the two as to why there's a discrepancy between the different scores they got. I also put in a GIF here, or 3 GIFs here of the different outputs. Here, the top is the ground truth, then it's the GPen output, and then below it is the real ESR GAN output. Then for my extra experiment, I wanted to sort of experiment what would happen if I ran the same image multiple times through these through GPen as well as real ESR GAN, and sort of see if it would sort of try to retain the image of what a quote unquote real human looks like, in a sense, as that was likely what they had trained on. But as I can see from my experiment, that running it multiple times definitely did not create anything resembling human. It created something more of like a cartoon block style, and I sort of went over as to why this might have happened, and as well as what this could tell us about how these different architectures work, inner working, and then sort of how they enhance the quality of the image they're given. And then to end it off, I talked about future projects and improvements. For example, one is incorporating annotations towards the training images for both the GPen and real ESR GAN, maybe to give as like a sort of quote unquote hint towards the model, such as, oh, this low quality image, the person in there is male. Maybe such things as person is smiling, emotion, kind of similar to how we had done it in assignment 4. And then I went through 2 others, sort of different improvements and then projects that it could be created. And that is all for my project. Thank you.